Moving forward with our trig unit, we are now ready to solve trig equations. When we're doing this, we're going to be focusing in on our unit circle values, so you want to make sure that you know your unit circle and you're familiar with your radians and your ratios. All right? So I started out with some very basic examples to show kind of what we're doing, and then I've got a couple harder problems here, and I'll come back with another video with harder examples. But as long as you know your unit circle, this is mostly understanding some algebra. So with this first example, this is asking what angle makes sine equal -1/2. If we were to go through and show the steps here, I need to isolate theta, so I'm going to take the sine inverse of both sides. So theta equals the sine inverse of -1/2. Again, that is asking what angle makes sine equal -1/2. So theta is going to equal, so sine is negative in the third and fourth quadrant, so that's going to be 7 pi over 6 and 11 pi over 6. Done. Okay, but if you think about the unit circle, if I just keep rotating around the unit circle, I'm going to have an infinite amount of answers. So I could just add 2 pi to both of those and just keep rotating around that unit circle, and I'm going to keep answering this question until I can no longer hold a pencil. So we're going to make a little bit of a restriction here. I'm going to say that I only want theta from 0 to 2 pi. So that way we're just looking at one rotation around the unit circle to find these ratios. Like I said, we're going to change and get harder problems, and that's when this is going to help us out or make things a little bit trickier. So we'll hold on to that. But again, we're just going to look at one rotation around the unit circle for now. So same idea here. I want to know what angle makes cosine equal 1/2. So we're going to see the cosine inverse of both sides. So I get theta equals the cosine inverse of 1/2. What makes cosine equal 1/2? That's going to happen in the first and fourth quadrant at our pi over 3's. So that's pi over 3 and 5 pi over 3. Boom. Those are the two angles between 0 and 2 pi where cosine is going to equal 1/2. So now we're getting into a little bit more algebra. The first thing I want to see, just like those two problems, I need an isolated trig function. So the first thing is I want to isolate that trig function, get it by itself. So here it's being multiplied by 4, so I'm going to go ahead and divide by 4. So I get the tangent of theta equals 1, and now I'm ready to take the inverse so I can solve. All right, so here I'm going to take the tangent inverse of both sides. So theta equals the tangent inverse of 1. Where does tangent equal 1? That's going to happen, positive 1 is going to be in the first and the third quadrant. So that's going to be at pi over 4 and 5 pi over 4. Okay? This one looks a little bit more complicated just because of the way this fraction is set up. But first thing I'm going to do is I'm going to minus 2 from both sides. So over here I get 2 sine of theta equals, this is over a fraction, so I need a common denominator, so I'm going to go ahead and make this -4/2. So now I have 4/2 minus 4/2. That's going to leave me with that 4√3. Okay, so this piece and that piece went to 0. So now I'm here, I'm still isolating sine, so I'm going to divide by 2. So I get the sine of theta equals, whoops, I did that wrong. Because that's going to give me 2√3, right? Because the 4 and the 2 are going to reduce. And guess what? Sine will never equal 2√3. Sine will never equal anything greater than 1 or less than -1. It's got to be between -1 and 1. So the way that I set this one up, unintentionally, is going to give me a no solution. Sine will never equal 2√3, so no solution here. Worth talking about, whoops, but that's how the cookie crumbles sometimes. Okay, so we got one more example over here, first thing I'm going to do is I'm going to divide by 6. So now I have the cosecant of theta equals 2. We might not remember our cosecant, secant, cotangents quite as well as we know our sine, cosine, and tangents. So we can go ahead and know that this is the reciprocal of sine. So this is the same as the sine of theta equaling 1/2. So here we're going to get theta is going to be equal to pi over 6 and 5 pi over 6. These two angles answer this question and this question because of that reciprocal relationship. Okay, go forth and solve. I'm going to come back with some harder trig type questions where we have to think about what happens if we have a period change or a phase shift. These things are important. We're going to come back and chit chat about those. Let me know if you got questions.